4 components. That is what we found inside. We bought 6 of the most popular energy-saving plug-in devices sold online. StopWatt, MiracleWatt, Pro Power Save, EcoWatt, VoltBox, and one with no brand name at all. We paid between $29 and $49 each. Then we cracked every single one of them open on a workbench. Inside each device, the same 4 things. A generic capacitor roughly the size of a thumbnail. A cheap varistor, the kind that offers less surge protection than a $10 power strip from a hardware store. A flimsy plastic housing, and a green LED light. That LED is the most insulting part. It exists purely to glow, so you feel like the device is doing something. In reality, that little light is the only component in the box that actually consumes electricity, meaning every single one of these devices technically increases your electric bill the moment you plug it in. These products are sold under dozens of brand names, and they all make the same promise. Plug this box into your wall, and your electricity bill drops by 40% overnight. Some of the ads feature fake endorsements from Elon Musk or Leonardo DiCaprio. Some create entire websites designed to look like CNN or Forbes. Some even spoof official government emails. And collectively, they have generated millions of dollars in sales. But here is the question that matters. Do they work? And if they do not, how did the scam get built, and what does it exploit? On Historia Prime, we usually travel deep into the past. Lost survival skills, forgotten hygiene practices, the ways our ancestors solved problems with what they had. Today we are still doing exactly that, because this scam is not new. It is built on a brilliant piece of 19th century physics that most people have never heard of. And to understand why the scam works psychologically, you have to understand why the physics works electrically. So let us go back, not to the internet age, but to the 1890s. Part 1. The Wizard of Schenectady. In the early 1890s, America was wired for war. Not a shooting war, a technological one. Thomas Edison was pushing direct current. George Westinghouse was backing alternating current. History calls it the War of the Currents, and alternating current won because AC could travel across hundreds of miles of wire where DC could not. But early AC power had a problem that nobody could fully explain. Engineers at power plants noticed that the electricity they generated did not match the electricity arriving at factories. Energy was vanishing somewhere between the generator and the destination. The numbers simply did not add up. The man who solved it was Charles Proteus Steinmetz. Steinmetz was a German immigrant who arrived in America in 1889. He was born with kyphosis, a severe curvature of the spine, and stood barely 4 feet tall. But his mind operated on a level that stunned everyone who encountered it. He first went to work for Rudolf Eichermeyer, an inventor and transformer manufacturer in Yonkers, New York. In 1893, the newly formed General Electric Company purchased Eichermeyer's firm, partly for the patents, but mostly because they wanted Steinmetz. GE relocated him to Schenectady, New York, where he spent the next 3 decades revolutionizing electrical engineering. In his own time, he was not obscure at all. Newspapers called him the Wizard of Schenectady. He served as president of the American Institute of Electrical Engineers. He was one of the most recognized scientists in the country. What Steinmetz figured out, through painstaking mathematics using complex numbers, was that alternating current carries more than one type of power. And to explain what he discovered, engineers have used the same analogy for over a century. It is simple, and it is perfect. Think of a glass of beer. The liquid beer, the part you actually drink, is called active power, measured in watts. This is the electricity that does real, physical work. It heats the coils in your toaster. It creates the light in your bulbs. It physically turns the motor in your washing machine. Active power is the only form of electricity you pay for on your home utility bill. The foam on top of the beer is called reactive power, measured in VARs. You cannot drink the foam. It does not quench your thirst, but it takes up space in the glass. Reactive power is a kind of phantom energy. It is absolutely necessary to create the magnetic fields inside electric motors and transformers. Without it, your refrigerator compressor could not start. But reactive power does no useful work by itself. It simply oscillates back and forth between the power plant and your appliance, 60 times every second, like a tide that never reaches shore. The entire glass, liquid plus foam combined, is the apparent power, measured in volt-amperes. It represents the total electrical demand placed on the grid. The ratio of useful beer to total glass is called the power factor. A perfect power factor of 1.0 means your glass is 100% liquid and 0% foam. A poor power factor of 0.7 means 30% of your glass is foam. The grid has to send you a much bigger glass just to deliver the liquid you actually need. Steinmetz did not just identify the problem, he figured out the fix. He demonstrated that connecting a device called a capacitor to the circuit acts like a sponge for the foam. The capacitor stores electrical charge and produces a current that cancels out the reactive current from motors. Instead of phantom power sloshing all the way back to a distant power plant, the capacitor recycles it locally, right next to the machine that needs it. By the 1920s, massive industrial factories across America were using banks of capacitors to correct their power factor. It saved them enormous amounts of money. It was a genuine triumph of applied physics. But here is the critical question that the scammers hope you never ask. If this technology works so well for factories, why doesn't it work the same way for your house? Part 2. The billing trick. They're counting on you not knowing. The answer comes down to one word: meters. Utility companies are not charities. When a massive steel mill with thousands of heavy motors creates a tidal wave of reactive power, that phantom energy clogs the utility's transmission lines. It causes wires to heat up. It wastes infrastructure capacity. The utility has to build bigger cables and transformers just to handle the foam. So utilities fight back. They install specialized, complex meters at factories and commercial buildings. Meters that record both the active energy in kilowatt hours and the reactive energy in kilovolt-ampere reactive hours. If a factory's power factor drops below a threshold, typically around 0.85, the utility hits them with a power factor penalty surcharge. It can add thousands of dollars to a monthly bill. By installing large capacitor banks, factories correct their power factor, avoid the penalties, and save real money. This is a documented, well-understood industrial practice. It has been standard for decades, and it is the tiny kernel of truth that the entire consumer scam is built on. Here is what the scam ads will never tell you. Your home electricity meter does not work the same way. Whether you have an old-fashioned mechanical meter with a spinning disc or a modern digital smart meter, residential meters in the United States are engineered to measure only active power. They measure only the liquid beer. They completely ignore the foam. In the United States, Canada, the United Kingdom, and virtually every developed country on Earth, residential customers are billed exclusively in kilowatt hours. You do not pay a power factor penalty at home. You do not pay for reactive power, period. So when you buy a $30 plug-in capacitor and stick it in your wall outlet, it might technically improve the power factor of your home's internal wiring by a tiny, almost immeasurable amount. In theory, this could reduce the current flowing through the wires inside your walls by a fraction, which means a fraction less heat loss in those wires. We are talking about savings on the order of pennies per year, far less than the cost of the device itself. Your utility bill will not change by a single meaningful cent, because the utility was never charging you for reactive power in the first place. You are buying a cure for a disease you do not have. It is the 21st century equivalent of snake oil from a traveling salesman in the 1800s. Part 3. The amps trick. How they fake the demo. If you have watched any of the promotional videos for these devices, you have probably seen the demonstration. A salesperson plugs a fan into a kilowatt meter. The display shows a current of 0.50 amps. Then they plug their magic box into the same outlet. The meter reading drops to 0.30 amps. They look at the camera and say, "Look, a 40% reduction." This is not a lie, exactly. It is something worse. It is a half-truth designed to mislead you. Here is what the demonstrator has done. They have deliberately set the meter to display amps, which measures total current, rather than watts, which measures real power. Because the capacitor inside the scam device neutralizes some reactive power locally, the total apparent current flowing from the wall does drop. That part is real physics. But at the exact same moment, the phase angle of the electricity shifts. Your utility meter calculates your bill based on voltage multiplied by current multiplied by the cosine of the phase angle. The decrease in current is mathematically cancelled out by the change in phase angle. The actual watts consumed, the only thing your meter records, the only thing you pay for, remains exactly the same. It is a parlor trick. The demonstrator is showing you the foam shrinking while the beer stays the same size. But since you only pay for beer, the shrinking foam changes nothing on your bill. Part 4. Fake news, deepfakes, and psychological warfare. When physics fails them, the scammers pivot to psychology, and they are disturbingly good at it. The marketing infrastructure behind these devices is sophisticated. They create entire fake news websites designed to look identical to CNN, Fox News, and Forbes. They publish fabricated investigative reports claiming the device is a breakthrough. They use unauthorized images and AI-generated deepfakes of public figures, Elon Musk, Leonardo DiCaprio, Joanna Gaines, to imply celebrity endorsement. To be absolutely clear, none of these people have anything to do with a $30 plastic plug. Tesla's energy division sells Powerwalls, sophisticated home battery systems that cost thousands of dollars, not cheap capacitors in plastic shells. Some of these operations have even sent phishing emails spoofing official government addresses to make consumers believe local authorities are mandating these devices. They exploit financial anxiety. They manufacture authority where none exists. They manipulate basic math into something that sounds convincing to anyone who is not an electrical engineer. It is a masterclass in digital fraud, and it works because the underlying physics is just complicated enough that most people cannot easily verify the claims on their own. Part 5. The part that should actually scare you. On Historia Prime, we talk about survival, knowing which water is safe to drink, how to spot danger before it reaches you, how to fortify your shelter against threats. In the modern world, survival means keeping unregulated hazards out of your home. And these devices are exactly that. These products are unbranded, drop-shipped items that bypass the rigorous safety testing required for legitimate electrical appliances sold in the United States. In April 2022, the UK's Office for Product Safety and Standards issued official recalls for multiple energy-saving plug-in devices. The recalls cited a serious risk of fire and electric shock. Testing revealed plug pins that were incorrectly sized and liable to break off inside wall sockets, capacitors that were unmarked, unapproved, and at high risk of short-circuiting, no internal fuses or proper protection, meaning if a surge hits, the device has no way to safely fail. It simply catches fire. In 2025, the UK consumer group Which tested 8 more of these devices purchased from Amazon, eBay, AliExpress, Shein, and Temu. None of them produced any measurable energy savings. All of them failed safety standards. Testers found poor soldering, excessive lead content, and non-compliant construction throughout. Think about what that means. You are stressed about rising costs. You spend $30 or $40 hoping to save your family a few dollars a month. And in doing so, you plug an unregulated, untested, potentially toxic fire hazard directly into the walls of your home. The device that was supposed to protect your budget could burn down your house. Part 6. What actually works? The financial pain is real. According to data from the US Energy Information Administration, residential electricity prices have climbed roughly 28% in nominal terms between 2021 and 2025, from about 13.7 cents per kilowatt hour to over 17.4 cents. Residential prices rose 9.5% in just the past year alone. The reasons are structural: aging grid infrastructure that needs hundreds of billions in upgrades, extreme weather events whose costs get passed to consumers, and explosive growth in electricity demand from AI data centers and electrification. We cannot control the macroeconomics of the national grid, but we can control what happens inside our own homes. And the real solutions are not mysterious or hidden. They are well documented, scientifically verified, and available right now. LED lighting, a straightforward upgrade. Incandescent bulbs waste roughly 90% of their electricity generating heat instead of light. LEDs convert nearly all their electricity into photons. Switching your entire home to LEDs can cut your lighting costs by up to 75%. No magic involved, just better engineering. Smart thermostats. Heating and cooling are the largest energy consumers in most American homes. A smart thermostat learns your schedule and adjusts automatically when you leave or sleep. The Department of Energy estimates smart thermostats reduce HVAC costs by 8 to 15% annually. That is real, measurable money back in your pocket every single month. Vampire loads. Many modern electronics, TVs, gaming consoles, phone chargers, never fully turn off. They sit in standby mode, quietly drawing power around the clock. The Department of Energy estimates that standby power accounts for 5 to 10% of residential electricity use. Simply unplugging idle devices or using a smart power strip that cuts power completely can save a typical household $50 to $100 a year. Air sealing and insulation. This is the oldest survival skill there is. Fortify your shelter against the elements. If your home leaks air through gaps in doors, windows, and the attic, your HVAC system works harder than it needs to. Adding weather stripping and upgrading attic insulation can reduce your heating and cooling bill by up to 15% permanently. Real-time energy monitoring. If you genuinely want to understand where your electricity goes, do not buy a fake capacitor. Buy a legitimate home energy monitor. Devices from companies like Sense or Emporia that clamp safely onto the main wires in your breaker panel and connect to your phone. They do not magically clean your power. They show you, in real time, exactly how many watts each appliance is drawing. Research consistently shows that when people can see their consumption in real time, they change habits and achieve genuine savings of 5 to 20%. None of these solutions promise 40% overnight. They require some effort, some investment, and some patience. But they work. They are backed by engineering, not marketing. One thing we never do on this channel is pretend that every problem has a DIY solution. If your electricity bill has spiked suddenly and you cannot explain why, the answer might not be a thermostat upgrade or a set of LED bulbs. It might be a wiring fault, a failing appliance drawing excessive power, or a meter error. These are problems that require a licensed electrician with proper diagnostic tools. If you suspect something is genuinely wrong with your home's electrical system, call a professional. No YouTube video, including this one, is a substitute for a qualified inspection. Conclusion. We started today at a workbench, cracking open a plastic box. Inside we found 4 cheap components and a green LED light designed to make you feel like something was happening. But to understand why that box exists, we traveled back to the 1890s and met Charles Steinmetz, the Wizard of Schenectady, whose mathematics explained how alternating current actually works. We learned about active and reactive power. We learned about the beer and the foam. We learned that power factor correction is a real, century-old industrial technology that genuinely saves factories millions of dollars. And we learned exactly why it does not save homeowners a single cent. Because your residential meter was never measuring the foam in the first place. The scammers who sell these devices did not invent new technology. They took a legitimate piece of physics and wrapped it in fake news articles, deepfake celebrity endorsements, and manufactured urgency. They are not geniuses. They are just counting on you not knowing the difference between amps and watts. Now you know the difference. The next time someone sends you an ad for a miracle plug-in device, or your parents ask you if they should buy one, you will know exactly what to say. You will know about the beer and the foam. You will know about the meter. And you will know that the real way to lower your electricity bill is not a $30 plastic box. It is knowledge. That is what this channel has always been about. The best survival skill in any century is understanding how the world actually works. If this investigation helped you see things a little more clearly, share it with someone who needs to hear it. That is how we fight back against scams, not with gadgets, but with information. Thank you for watching Historia Prime. I will see you in the next one.